Hi everyone. So today's video is going to be just a little bit different. As you are going through the notes in this video, it's going to start pausing at some places. And basically what I want you to do is just do your best to apply what we just talked about or the formulas that we just went over. See if you can do your best to answer the questions as they come up in the video. Let's go ahead and get started. So here are your notes for 1.8, variance and standard deviation. Now, the first thing I want to talk about is the range. You may or may not remember this, and that's quite all right, but let me just remind you. The difference between the maximum and the minimum data entries in your data set is what we call to be the range. If we are finding the difference between the maximum and minimum, this means that they have to be numbers. You can't subtract categories, such as the color of eyes. Right? You can't subtract a blue eye from a brown eye. It doesn't quite make sense, which is why your data must be quantitative. So what you could do instead is you can maybe take a look at the number of people who have blue eyes and the number of people that have green eyes or brown eyes, right? That makes your data quantitative. All right, and just a reminder once more, to find the range, you take your maximum and subtract out your minimum from that. All right, so here is our first example in finding the range. 2 corporations, each hired 10 graduates. The starting salaries for each graduate are shown in thousands. Please keep that in mind. Find the range of the starting salaries for Corporation A. All right, so listed right here is the starting salaries for Corporation A. In order to find the range, what we need from our formula was the maximum and the minimum. And the fastest way to do that is to reorder your entire data set so that we can quickly find our minimum as well as our maximum. And then all we need to do is substitute straight into this formula. And subtracting 47 and 37, we find that the range is 10. But again, keep in mind that this is not our final answer. The final conclusion is that the range of starting salaries for Corporation A is $10,000. So what this means is that it starts from $37,000 and it ranges all the way through up until $47,000. That's what it means to have a range of $10,000. All right, now let's go ahead and let's talk about deviance, variance, and standard deviation. So, deviation. The word deviate means to move away from or get away from, right? And so deviation actually measures, right, because we're working with numbers, how far a data entry is away from the mean, quite literally. So what that means is that in order to find the deviation, you take the difference between the data entry, xi, and the mean of the data set. So what that looks like in a formula is to find the sample deviation, you take the data entry and subtract the mean from it. Symbolically, it looks like xi minus x bar, right? And keep in mind, this data entry, we are going to do this for every single data entry because that's what we're going to use to find the variance and standard deviation. All right, now sample variance. This is how we find the sample variance. It looks a little crazy, but I promise it's not. Variance is denoted by this s squared. It's not just s. You'll see what s is in just a moment. But s squared is your sample variance. And when I say sample, I mean the sample of our study, whatever it is that we're pulling data from. This variance is equal to the sum of every data entry minus the mean, and we take whatever number this is and you square it, and then you divide by n minus 1, where n is the total number of entries. And the reason why we subtract 1 is, again, keep in mind that a sample is only representative of your population. It's not actually your entire population. So that's why we need to subtract out the 1 to kind of calculate in our error, so to speak. But again, variance is going to be equal to all of your data entries subtracted from the mean, and you're going to square every single one of those, and then add them all up, and then divide by n minus 1, and that is your sample variance. Once you have your sample variance, finding your sample standard deviation is literally just one more step. Your sample standard deviation is your S. So if sample variance is S squared, then to get S, you take the square root of S squared, and that's the same thing as taking the square root of all of this stuff that you calculated earlier. All right? So let's go ahead and let's put this into practice. So here again is the starting salaries for Corporation A. Same list of salaries or numbers from earlier. What we're going to do is we're going to find the sample variance as well as the sample standard deviation for these starting salaries. All right, so the first step in finding the sample variance is something that we've done many times already, and that is to find the mean. To find the mean, you already know how to do this. It is x bar, right? We're using the symbol to signify the mean. You add up all of your data entries and divide it by n. What this is 415 divided by 10, and we get that our mean is exactly 41.5. This actually means that the mean starting salary or the average starting salary is $41,000 and $500. All right, the next step in finding the sample variance as well as the standard deviation is to find this. In other words, we are finding the deviation, which is taking every data entry and subtracting the mean from that. So what I suggest is you make a table just like this, where one column has every single data entry, and your second column is where we're going to find all of those deviations. You're going to take xi and subtract x bar from every single one of these. And then last but not least, what we're going to do is we're going to square everything that you got in the deviation column. So keep in mind again that the average that we found from earlier was 41.5 or 41,500. So we will take our data entry, 41, subtract out our mean, and that gives us a deviation of -0.5 or -0.5. If we go ahead and square that number, which is what it asks us to do here, we will get 1/4 or 0.25. All right, and then what you're going to do is you're going to finish up and do the remaining of these deviations. You can go ahead and check your answer here. We go ahead and take every single data entry, as you can see on the left side, and we are subtracting the average or the mean from each of those entries. And that gives us a deviation. Then we take all of these deviations and we square them like so. Once we have squared it, the last thing we need to do according to step 2 is to sum it all up. That's what the summation symbol means, right? Order of operations, do everything on the inside. That's your deviation. Then take care of anything on the outside of the parentheses, squaring everything. And last but not least, summing it all up. And that gives us our sum to be 88.5. All right. Last step in finding the sample variance. What we did earlier with that table is we have found the numerator for your variance. So this step is actually done. But what we need to still do is divide by n minus 1. So substituting in what we got after subtracting every data entry with the average or the mean, and then squaring it, and then summing it all up, we got 88.5 from earlier. We need to divide it by 10, because if you counted the data entries from our example, we actually had 11, right? 11 total entries. So 11 minus 1 is 10. And this gives us 8.85, or a sample variance of about 8.9. Now, from here, what we want to do is we want to find the sample standard deviation. To find the sample standard deviation, which is just S, all we need to do is simply take the square root of our sample variance. So, taking the square root of 88.5 divided by 10, or you could go ahead and take the square root of 8.85 here. That gives us about 2.9748, which we can go ahead and round off nice and neatly to 3.0. All right, so what this means is that the sample variance is about 8.9, or technically $8,900, and the sample standard deviation is about 3.0, or $3,000. Now the question then becomes, well, why is it important for us to find the sample variance or the sample standard deviation? All of this is about finding how far away you are from the mean or the average. In other words, how far away are you from a typical measure or a quote-unquote normal measure, right? How or what value could we typically expect most of the time? And we do know that sometimes there's a little bit of error, and that error is what's calculated into the standard deviation. And it tells us what we should get most of the time. So, interpreting the standard deviation, kind of what I just mentioned. Standard deviation is a measure of the typical amount an entry will deviate from the mean. In other words, it tells us kind of on average how far away we might be from the actual average itself. Or normally, how far away can we expect a starting salary to be from the average? Because we know that if we were to, say, go and get hired at different companies, it will vary the starting salary from place to place. But if we know what the average is, we know that we can expect a starting salary of around that much, maybe plus or minus the standard deviation. So the more entries that are spread out, the greater the standard deviation. Now, what that basically looks like on a graph is like so. Here we have, there seems to be 8 data entries because we have a frequency of 8. So there are 8 data entries and they all measure 5. Every single one is 5. And so the average then, of course, is 5. That's where the X bar is. And our standard deviation is 0. In other words, none of our data entries deviate or are far away from our average because they all are our average. So of course the standard deviation is 0. The second table here, we see that not all 8 entries are at 5 this time. We have about 4 entries at 5. There are 2 entries at both 4 and 6, and then we have 1 entry at 3 and 7. So as we can see here, we have more entries that are further away from the mean. And so because of that, our deviation, or our standard deviation is about 1.2. So we can expect a value to be around 5 or within 1.2 values of 5. And if we were to subtract 1.2, that will get us to about 2.8, and 3 is still within that. And if we were to add 1.2 to 5, that gives us 6.2, and that lands us right about here in 6. All right, last but not least, here is an exceptionally good example of how standard deviation works. We have 3 entries at 2, and we have 3 entries at 8. We have 1 entry at 3 and another entry at 7. And if I were to find the average of 3 2s, 1 3, 1/7, and 3/8, we actually find that the average is still 5. But the standard deviation here is 3. It is much larger than this second graph right here. And that has to do with the fact that all of our entries are pretty far away from our average, which was 5. In fact, we don't even have any entries that are 5. And so this shows us that the data is more spread out because our standard deviation is much larger than, say, the second one right here. And we can even see that visually, right? All of our entries are either to the left or the far right of our average. All right, so here's another good one to think about. The starting teacher salary for a lot of cities in the Bay Area or a lot of districts in the Bay Area are listed right here. This, I believe I pulled from 2019 or maybe 2018, but pretty recent. Now, if we went ahead and found the average of all of these salaries, the average is about $56,500. We can see that Oakland starts at $46,000 and New Haven here in this district starts at $71,000. So already we can see that our minimum and our maximum are quite far from our average, right? I would say about 10,000 for the minimum and about 15,000 for the maximum. So quite a large distance between the mean and these two entries. Now, if we went ahead and calculated the standard deviation, that would give us about $8,800. So what this means and how we interpret this, because again, standard deviation tells us where a typical entry will fall compared to the average. We can expect, knowing that the standard deviation is about $8,800, a teacher who wants to start working in the Bay Area can expect a starting salary of about $56,500 because again, this is the average, but we can plus or minus $8,800. In other words, they can expect to make about $8,800 less than $56,000, or they can expect $8,800 more than $56,000. And this is what we would say to be a typical starting salary. Again, a pretty large standard deviation because $8,000 starting salary means quite a lot, especially if you're paying for, say, mortgage, bills, car insurance, hospital insurance, etc., right? All that stuff. $8,000 is quite a huge difference. All right, so for these next few graphs, see if you can figure out what the sample standard deviation is without actually calculating it. All right, so here is the first graph. I do realize that it says N and mu. N is simply just the total number of entries or frequencies, and mu is your average. Think of this as your X bar. Okay? So our average is 4, and the total number of frequencies or entries is 8. What do you think the standard deviation is for this first graph if every single entry falls on the average? All right, and because every single entry falls on the average, none of them are far away or go away from the average, this actually has a standard deviation of 0. Because again, none of these entries are far away from the average or the mean at all. For our second table, we notice that we still have a frequency of 8 and we still have an average of 4. Right? Here's our average of 4. But now half of our data is on 3 and the other half of our data is on 5. So see if you can just guess what our standard deviation is. All right, I'm going to go ahead and take a guess. I think it should be maybe around 1 or so, because all of our entries are on either 3 or 5, and each of these are 1 unit away from 4. And double checking my hypothesis, looks like we are correct, right? And again, you can see that because our average is 4 and all of our data entries are on either 3 or 5. In other words, we either went 1 less from 4 or we went 1 above 4. All right, here is our final graph. See if you can figure out what the standard deviation is given the same frequency or data entries, 8, and the same mean, which is 4. All right, so this one's going to be a little bit larger than a standard deviation of 1 because I now have some entries that are all the way over at 1 and some entries that are all the way over at 7. So my data entries have become more spread out and further away from 4. So I should expect a larger standard deviation than 1. How much? Not quite sure. I just know that it's larger than 1. And if you were to calculate it, it looks like you would get about 2.2. And again, we can verify that knowing that our data has gotten further away from our average. All right, so this last page here is some functions that you can type into Google Sheets, and these will basically automatically find any of these for you. Because if you notice, when you tried doing the standard deviation by hand, you had to subtract out the average from every single data entry, and you only had to do that for 11. Now imagine working with statistics or working with real data, you would have hundreds of data entries to work with. And that becomes not impossible, but quite tedious to do by hand. And so there are calculators such as Google Sheets or a graphing calculator or Excel that is programmed to do all this for you. You just have to make sure that you are typing in the correct function. Now, the other thing I wanted to mention is that you can see here we have population variance as well as population standard deviation. The reason why I didn't mention these in the notes is because typically we are almost always working with your sample variance. In other words, we are taking a sample of our study group or our study population, whatever it is that we're trying to do a study or a survey on. And this is going to be a sample of what we're working with. It's not going to be the entire group most of the time. But if you were to, say, gather data from every single person that wants to be studied or every single thing that you are trying to study, then we would go ahead and use the population standard deviation, which divides by n instead of n minus 1. All right, so that's it for variance and standard deviation. Thank you so much for watching.